An experiment involved using a constant power supply to melt 1 kg of ice, to heat the water produced, and then to turn all the water into steam. Which graph best shows how the temperature T varies with the time T for this experiment? Take note that the temperature T, the T for the temperature is capital T, and the T for the time is a small t. In the graph given, the horizontal axis is for time T, and the vertical axis is for temperature T, capital T. Now, the first questions that we might ask when you try to solve this question is, what is the initial temperature of the ice? This information is never provided by the questions. The question never mentioned about this. But if you look at the graph given, A, B, C, D, we can see that all of the initial temperature when the time T equal to 0 are the same, which is 273 Kelvin, 273 Kelvin, 273 Kelvin, 273 Kelvin. So that means the initial temperatures of the ice is 0 degrees C, which is equivalent to 273 Kelvin. The next questions, or the next informations we can try to get from the question is about the whole process that undergone by this system. When we heat the ice, what are the process that undergoes by the system? So we need to have the pictures of the whole process. From the statements given in the questions, you see, we use a constant power supply to melt 1 kg of ice and to heat the water produced, and then to turn all the water into steams. So that means we can know that initially the system is composed of ice, and then because of the heating, it changed to water, and after that it will change into the steams. So that means the system that we study undergoes 3 stages or 3 states for the system that we study. Initially is ice, followed by water, and then the steams, because of the heat absorbed by the system. The ice, when we apply heat to them, it will start to melt, and then after that it changes to water completely. Now, and if we continue to provide the heat to the water, then the water will increase its temperature until it achieves 100 degrees C, and it starts to change into the steams. Now, if we know that these systems undergoes 3 stages, then we can check whether it is reflected in the graph or not. If we look at A, we can see that there are 3 stages reflected in the graph. Firstly is this horizontal line refer to the ice, okay, and after that the water's temperature increased from 0 degrees C to 273 Kelvin to 373 Kelvin, corresponding to or equivalent to 0 degrees C to 100 degrees C, and then after that it becomes the steams. So that means graph A shows the 3 stages of this process, okay, undergoes by the system. Similarly for B, B also reflects 3 stages for the system, ice, water, and the steam. D also the same, ice, water, and the steam, except for the C. Now C is, there is only one stage, which is the water, because the temperature now changed from 0 degrees C into the 100 degrees C, or 273 Kelvin to 373 Kelvin. So that means by considering the number of stages and go through by these systems, then we can know that the option C cannot be the answer. So we can exclude the C first. We can sure that C is not the answer. But the remaining options A, B, and D, which one is the right answer? To know about that, then we have to consider another questions. We have to ask another question. Which state requires more times? Okay. In state number 1, let me call this as a state number 1 for the ice transform into water. State number 1. For water transform into for water to change the temperature from 0 degrees C to 100 degrees C, we call it a stage number 2, and then for the boiling water at 100 degrees C transform into the steam at 100 degrees C, we call it as a third stage. So we can calculate the quantities or the total amount of the heat that need to be provided by this power supply to the system for these 3 stages. Firstly, which is the for the ice to transform into the water. This involves the process of the fusions. So we can find the heat, the total amount of the heat needed to make this happen is the Q1 equal to mLF. LF is the specific latent heat for the fusions. Okay, which is it takes the value 3.35 times 10 to the power 5. And the M is 1 kg, so we have this value 3.35 times 10 to the power 5 joule, which is the heat required to transform the 1 kg of ice at 0 degrees C into the water of the 0 degrees C. The temperature in the whole process of the first stage, the temperature is the same, but that involve the transformations of the state, which is from solid into the liquid. Now we can calculate the heat required to increase the temperature of the water initially at 0 degrees C to 100 degrees C boiling water by using the formula Q2 equal to mc delta T. The subscript 2 indicates the second stage. So M again is 1 kg and the C is the specific heat capacity of the water, which is 4186 joule per kg per Kelvin. And delta T is 100 because the temperature changes from 0 to 0 degrees C to 100 degrees C. So we can find this quantity 4.186 times 10 to the power 5 joule, which is the quantities of heat required to transform the water, to change the temperature of the water, 1 kg of water from 0 degrees C to 100 degrees C. And for the third stage, this third stage, because it involves the transformations for the 100 degrees C boiling water into the 100 degrees C steams, then we can use this formula Q3 equal to mLV to calculate the heat required, where the LV is a specific latent heat of the vaporizations, which is 22.6 times 10 to the power 5. So the answer is 2.26 times 10 to the power 6 joule. Now, from the result of the calculations that we have, we can easily see that for the stage number 1, the quantity of heat required is the smallest. Second largest is the Q2 and the largest one is the Q3. Now, because the power supply that we have is the constant power supply. What is the meaning of constant power supply? Constant means that in every second, the quantity of the heat that can be provided to the system would be the same. In 1 second, the quantity is a fixed value. So that's why we call it a constant power supply. Now, if the power supply is a constant one, so that means we will take more times if the Q value of Q will be larger. Okay, so if we compare these 3 quantities, we know that for the stage number 3, the system will take the largest times to complete complete this stage number 3. Okay, and the stage number 1, the time required is the shortest. It's the shortest for the ice. Time required is the shortest for the ice to 1 kg of ice to transform from 0 degrees C into 0 degrees C of the water. Okay, and this one is the second largest for the longest time. Second longest time for the 0 degrees C of water increase the temperature to 100 degrees C of water, which is a boiling water. And this one is the longest. For the 100 degrees C of boiling water to transform into the 100 degrees C of the steams. So these comparisons or the differences of the times should be reflected in the graph, because one of the axes for the graph is the time t. So if we look at A, B, C, we know that we compare for, let's say for A, different stages, the time which one is longest, we will see that the first stage is longest, and then the third stage is the shortest, which is not the same as the information we can get from our calculations. Because from our calculation, this first stage, the time is the shortest, but in the graph A, it is the longest compared to the second stage and the third stage. And the B, you see the first stage and the third stage, the time taken for the system to hit the system is the same. Okay, the longest one is the second stage. Second stage is the longest. So that means this B also cannot be the answer. Now look at D. Now look at D. You see D, the first stage, the time is the shortest, and the second longer is the second stage, and the longest one is the third stage. So that means it is matched with the informations that we have based on our result of calculations. So that means the answer is D. Okay. So to summarize, I hope we can, you all can see the pictures of the big pictures of how we solve the questions. Actually, we just need to consider two factors, two things to get the answer. The first one is number of stages. Okay, when we heat the ice and transform them completely into water, how many stages it undergoes for the system to change from the ice into the steams? It is 3. So that means from these first factors that we consider, we know that the answer C must be excluded. And then if we consider times taken for the complete process taken by the system for 3 stages, then we can know that the answer should be the D. Okay, because the time required to transform from this boiling water into the steams is the longest based on our calculation, and it is reflected by the graph D. Okay, so that means we know that the answer is D based on these 2 factors that we consider. We can know that the answer is